Hey guys, so hope you are ready for a wild lesson today. So we are going to start talking about trig identities. So the first thing we're going to do is talk about them, and then I'm going to show you how to verify them. So let's get started. So all of these identities right here, okay, are your fundamental identities. They are the identities that you really need to know. Some of them we've already talked about. Some of them might be a little new. So here we go. Reciprocal identities. So I'm going to talk about these first because we know that cosecant is the reciprocal of sine. We know that secant is the reciprocal of cosine. And we know that cotan is the reciprocal of tan. But I want you to know, or notice, I guess I should say, if you look at these reciprocal identities here, sine can actually be written as this because that is actually 1 over sine, and then we multiply by the reciprocal, and notice we get sine, okay? So notice that sine, cosine, and tangent can all be written as 1 over the reciprocal. So 1 over cosecant, 1 over secant, and 1 over cotan. Okay. Quotient or ratio identities, notice that that is just the definition of cotangent and tangent. Okay. So we have tangent is equal to sine over cosine, and we have cotan is equal to cosine over sine. Even and odd identities, remember we talked about how cosine is an even function. So if we plug in the positive angle and the negative angle, we get the same value out. Okay. And then notice we talked about sine and tangent being odd, so that when we plug in the negative angle, we get the opposite of the positive angle. Okay. The biggest ones I'm probably going to talk about are the Pythagorean identities. There's a couple things that I want you to see about these. Okay, let's switch this to black. Okay, I am going to rewrite sine squared plus cosine squared equals 1. Okay. I want you to notice, and I'm going to talk about this one first. Okay. If I divide everything by cosine squared, okay, I get that. This right here can be written as tangent, which is right here. Cosine squared divided by cosine squared is 1. And then 1 divided by cosine squared is secant squared. Okay. Then I'm going to rewrite it again. Oops, equals 1. If I divide it by sine this time, I will get everything for this one. Sine divided by sine is 1. Cosine squared divided by sine squared is cotan squared. And 1 divided by sine squared is cosecant squared. So if you have one of these identities, well, I should say the first one, the sine squared plus cosine squared equals 1, you can divide by cosine squared or sine squared and be able to get the other two. So in case you ever forget them, that's a way to be able to find them. So now let's talk about rearranging them, okay? So every single one of these can be rewritten 2 more ways. So think about it here. If I wanted this to say sine squared, what would I have to do to both sides? And hopefully you said subtract cosine squared, okay? If I want this to be solved for cosine squared, hopefully you said that I would have to subtract sine squared. So notice sine squared plus cosine squared equals 1 can be rewritten 2 more ways. Okay, let's look at the next one. So the next one already says secant squared is equal to tan squared plus 1, but let's see what else we can do. So tan squared would equal secant squared minus 1. I could also say 1 equals secant squared minus tan squared. Okay. And then for the last one, we already have cosecant squared equals 1 plus cotan squared, but let's rearrange them again. So 1 is equal to cosecant squared minus cotan squared. And cotan squared is equal to cosecant squared minus 1. Okay, so I don't know how you guys print off your notes, but one thing that I would do is be able to have this first page available 24/7 when we go through the notes and when you guys go through your homework. Okay, so before we dive into verifying, there's some things that I would like to talk about. So work with each side of the equation independently of the other side. Typically, we start with the more complicated side and transform it step by step until it looks exactly like the other side. We are not solving these equations, we are verifying them. So the goal is to get one side to look like the other side. Okay? So we have to analyze and identify and look for opportunities to apply those fundamental identities. Okay? And here are some steps that you can use. Rewrite the more complicated side in terms of sine and cosine. Factor out the greatest common factor possibly. Okay, this right here, don't know how well you guys are with your fractions, but hopefully you're pretty well familiar with it. You're going to be able to, you need to be able to know that if I have a plus b over c, I can split it up, or vice versa. I can add them together and make it one fraction. And the same thing for subtraction. Combine fractional expressions like I just talked about with that least common denominator. And then multiply the numerator and denominator by a binomial factor that appears on the other side of the identity. I don't actually know how much we use that one. So I'm going to leave that one alone for now. But this last part is very important. Don't be afraid to stop and start all over again if you're not getting anywhere. Okay, because creative puzzle solvers know that strategies leading to dead ends often provide good problem-solving ideas. Don't be upset if you get stuck on one of these. Just calm down your brain and focus, take a break, and then come back and look at them again. Okay, so we're going to get started. I tried to space these out to give us enough room. So we're going to get started. So remember one of the main things that I said, we want to make sure we don't solve these equations. We're making one side equal the other side. So we're going to start off a little bit easier, and then these are going to get harder. So notice I have a more complicated side on this side. This side is just tan. So let's try to make this side equal tan. So what I want you to do is try to have that first page of notes available. What is something that you can see on that first page of notes with all those fundamental identities that we could change? Hopefully, you said secant. Okay? So I can change that to 1 over cosine of x. Now, I'm going to try to switch my colors often to try to help so that you can see what all we're doing. So I'm going to rewrite my sine of x right here. Okay, so I'm going to make it a little bit higher, about right here. So we changed everything that we could. Okay, so we're going to go ahead and use algebra and multiply. So sine of x times that 1 is sine of x. And then this is understood to be over 1, so 1 times cosine of x is cosine of x. Notice what this is. Okay, so if I change this to pink, okay, sine of x over cosine of x is known as tan of x. So we were able to make our left-hand side equal our right-hand side. Okay. Okay, so let's see what else we got here. So the next one, we want to probably try to get it to equal the negative sine x, because this left-hand side is going to be a little bit more complicated. So we know that we can change this. So tangent of a negative x is the same thing as negative tan of x. And then I'm going to rewrite my cosine of x. Okay. Then what is the definition of tan? Well, the definition of tan, we're going to change that, is, oops, I need a green, sine of x over cosine of x. And so I'm going to rewrite everything else around it, my minus sign, my times, my cosine of x. So notice here we can just do some algebra. Cosine and cosine cancel. I'm left with negative sine of x, and that equals our right-hand side of negative sine over x. Okay. Okay, let's go look at C. So we definitely have a less complicated side on this side. So that means we probably need to focus on the left again. So our goal is to get it down to cosine. So what could we do? Well, notice that these both have secant. So let's try to start the problem out by taking out our secant. So that would be left with 1 minus sine squared. Okay, now there's a couple things that we can see here. One, we have a secant. So let's try changing that to 1 over cosine of x. Okay, then we just learned what 1 minus sine squared is. So if you look right here, 1 minus sine squared is cosine squared. Whoops. So we're going to change that to cosine squared. So notice if we were to multiply these, 1 cosine on the bottom will cancel with 1 cosine here. So we get cosine x equals cosine x. So we got it. So this one took a little bit of factoring, changing, and then reducing. Okay? So let's go look at D. Got a lot of craziness going on here. So let's start to try to find this side. Okay, because notice we have a sine squared, we have a sine squared, and we know of something that can make this be sine squared. So let's try to do that first. So cosine squared, and we just used that, is 1 minus sine squared. And then we have minus sine squared x. And then notice we have the same term. So what's a negative sine squared minus sine squared? And hopefully you said 2 sine squared. And notice now we have the other side. Okay, let's go look at E. So we have sine squared minus secant squared minus, oh my gosh, can't get my words out. We have secant minus sine needs to equal cotan times cosine. Let's try to get the right hand side again. Let's see what we got here. So let's start off with this. Cosecant, we know, is 1 over sine. And then we're going to minus sine. Okay, so this is the part where I was mentioning about the fraction. So if you have fractions, let's find that common denominator. So remember that this is over 1. Our common denominator would be sine. So that means I would need to multiply this by sine and multiply this by sine. So we would end up having 1 over, let's go ahead and write it as one fraction. So this one wouldn't change, but sine times sine is sine squared. And this would be over sine. Okay? But we have seen this on repeat lately. 1 minus sine squared is cosine squared. Okay, and then we're going to separate these, okay, because notice what we're trying to get. We're trying to get cotan. So notice if I separate cosine over sine times cosine, that this right here changes to cotan. And now that can be multiplied times our cosine, and notice what we got, our right hand side. So we got it. Okay. Okay, well, we're definitely going to make the left side look like the right side on this one, because we just got to work it down to a 1. So we have the 1 squared times 1 minus cotan squared. So let's go double check that 1 plus cotan squared. So if we come back and look at this page, if you look right here, 1 plus cotan squared can be changed to secant squared. So let's start off with that. And we're going to change that to that secant squared. And then there's our sine squared. Okay. Hopefully you can see that we need to change this to 1 over sine squared. And then when I multiply that times sine squared, they cancel and we get 1 equals 1. Okay? I hope you guys are doing okay. I'm trying not to go too fast, but everything that we're using is going to be off this page right here, besides our algebra skills. Okay? So let's go to page 3. Okay. So let's look at G. We have sine of t times tan of t. And then 1 has to equal 1 minus cosine squared of t over cosine of t. I think we should work on the right hand side this time, because when I'm looking at this, what do we know that 1 minus cosine squared of t is? And hopefully you said it, sine squared of t. And then want to write that over cosine of t. Okay, so this is kind of like what we did just a second ago. Notice I need sine, I have one of those, and I need tan, which is sine over cosine. So we're going to split these up again. So I'm going to have sine of t times sine of t over cosine of t. And then here, we know that sine of t over cosine of t is tangent of t. And notice that matches. Okay. Okay, let's look at this next one. Oh, mine printed funky on this one. So this should be secant of t. So we have tangent squared of t over secant of t equals secant of t minus cosine of t. I say let's try to do that top one, or the left-hand side, and focus on that top, because we know tangent squared is equal to secant squared minus 1. So let's try that first. So we said that that is secant squared of t minus 1 over secant of t. So let's see what we got going on. Now notice we need a secant. We have one. Cosine is 1 over secant. So let's try splitting this up into two separate fractions. So secant squared of t over secant of t minus 1 over secant of t. So here, secant will cancel. So we're left with 1. And then minus 1 over secant of t is cosine. And so therefore, we got our right-hand side. I don't know what happened when this page printed. I'm missing sine of t here, and then over on that next one we're going to do, looks like I'm missing an x here and an x here. Okay, so we got tangent plus cosine over 1 plus sine has to equal secant. So probably going to try to do the secant thing. So let's see what we got. Let's start with changing tan. So we have sine of t over cosine of t plus cosine of t over 1 plus sine of t. Well, we have two separate fractions, so let's at least try combining them and see what happens. So we need that common denominator. So it looks like the common denominator will be cosine of t times 1 plus sine of t. So that means this one has to get multiplied by 1 plus sine of t. What you do to the bottom, you do to the top. So this is probably going to have a big fraction right here. So this looks like this would give us sine of t plus sine squared of t. It looks like this side is missing the cosine of t, so we're going to multiply by cosine of t. Cosine of t times cosine of t is cosine squared of t. And I'm hoping you're screaming at me right now, saying, hey, we got a sine squared plus a cosine squared. And what does that give us? 1. So we're going to have sine of t plus 1 all over cosine of t, 1 plus sine of t. Notice these are the same thing. We get 1 over cosine of t. And hopefully, oops, I've already used that one. We need green. We have 1 over cosine of t, and that changes to secant. And notice that is exactly what we needed up here. Okay. Okay, let's look at this next one. We need 2 secant, so that is definitely the simpler side. So let's start with the more complicated side. So I think we're probably going to have to do exactly what we just did on this one over here, is get that big, huge common denominator. So it looks like it's going to be cosine of x and then 1 minus sine of x. So that means over here, we would multiply by cosine of x, and cosine times cosine is cosine squared. Over here, we're going to multiply by 1 minus sine of x. Okay, so let's go ahead and FOIL that out. So we have a plus sign, so our signs won't change. So 1 times 1 is 1. 1 times negative sine is negative sine of x. Negative sine of x times 1 is negative sine of x. And negative sine times negative sine makes a sine squared of x. So kind of just like the other one, you should be screaming at me. Cosine squared plus sine squared is equal to 1. And then I'm just going to go ahead and drop this. However, negative sine minus sine is a negative 2 sine. All over cosine of x, 1 minus sine of x. So 1 plus 1 is 2. Oops, minus. Okay, notice that we have 2 2's, so we can take a 2 out. So we're left with 1 minus sine of x over cosine of x times 1 minus sine of x. These cancel, so you're left with 2 over cosine of x. And what that means is 2 over, oops, sorry, not here. 2 times 1 over cosine, and 1 over cosine is secant. So notice if I zoom out a little bit, that is exactly what we needed there. So we got it. Okay. Okay, let's go to the next page. Oh, we're missing something at the top here. So I don't think we're missing anything on that one, but we're missing a 1 right there. Okay. So we got secant squared x times cosecant squared x equals secant squared x plus cosecant squared x. Let's try to do the left-hand side. And I think what I'm going to do on this one is I think I'm only going to try to change one first. So let's change secant squared. And if we go all the way back to that first page, secant squared is equal to tangent squared plus 1. Because I don't want to change the other one, but because we have to have a plus sign somehow. So I'm going to just try to change one first. So let's see what we get here. We're going to have tangent squared times cosecant squared plus cosecant squared. Okay, let's see. Oops, my C didn't go. There we go. Let's see what happens when we try to change. Now, I need a cosecant, so I'm not going to mess with that one. But let's see, because this matches this. So we're going to see if we can change this to match this. Okay, so we're going to go change those. So we'll change this one and this one at the same time. So we know tangent is sine over cosine, so sine squared over cosine squared. We know secant is 1 over sine squared. Okay, and I'm going to drop this down. Okay, sine squareds cancel. You get 1 over cosine squared plus cosecant squared. And then what do we know 1 over cosine squared to be? And hopefully you said secant. And that is exactly what we needed. These match. So we did it. Okay. Okay. Let's look at this next one. So we have secant x minus cosecant x all over secant x plus cosecant of x has to equal tan of x minus 1 over tan of x plus 1. Let's see. Let's look at this more complicated side. So let's change everything. Okay. So here we go. We're going to change those secants. And we're going to change the cosecants. So we're going to have 1 over cosine of x. And then while I have my same color, I'm going to go ahead and write it. We know that this one's going to be minus, this one's going to be plus. There's my fraction bar. And we're going to change this to 1 over sine. 1 over sine. Made that a little too long. Okay, so let's work on that common denominator. So it looks like cosine times sine is going to be our common denominator. So that means this one gets multiplied by sine. So this will be sine of x minus this one gets multiplied by cosine of x. Okay, now this is all over. And it looks like we're going to get the same common denominator. I'm going to write them right next to each other. But this one again, just like we did, this will get multiplied by sine. And this one will get multiplied by cosine. Okay, so we have a fraction within a fraction on the numerator and the denominator, so we can't have this. So I'm going to zoom out because we're going to multiply by the reciprocal. Okay, so notice these cancel, these cancel. Notice up here though, these cancel. So I'm left with sine of x minus cosine of x all over sine of x plus cosine of x. Okay, now I want you to try to see what we have here. We have to get to tan minus 1. So notice we have our signs right, but I want you to think about this. If I need to get a 1 in this spot right here, what could I technically divide that by to get it? And hopefully you said cosine, and that's exactly right. So what we're going to do, if it'll let me change my colors. There it goes. We are actually going to multiply the top by 1 over cosine, but we're also going to multiply the bottom by 1 over cosine. Okay, so because I'm running out of room, I think I'm going to take the problem this way. So that means we're going to get sine over cosine minus cosine over cosine all over sine over cosine plus cosine over cosine. So we know that sine over cosine are tangents. So we're going to get tangent of x. I'm going to go ahead and write this one in green. And then minus cosine divided by cosine is 1. And then, of course, cosine divided by cosine is 1. So notice it took a lot, but this matches that right there. So we finally did it. Okay. Okay, I'm going to zoom back in. Okay, it looks like I'm missing something here too. This should be a cosine. Okay, so that should be it. Okay, so let's look. Definitely need to work on the left-hand side to get it to equal the right-hand side. But do you, by chance, see that this right here is a difference of squares? Okay, so if you have forgotten what that is, it's a squared minus b squared equals a minus b times a plus b. Okay, so in this case, a is sine, cosine is b. So we're going to write sine, oops, not squared, sine x minus cosine of x times sine of x plus cosine of x. Okay, and that is going to be all over sine of x plus cosine of x. Well, if you notice, these cancel, and you're left with sine of x minus cosine of x, and that was exactly what we needed. Okay. Okay, let's look at the next one. We have tangent squared of theta plus 1, and then cosine squared of theta plus 1 equals tan squared theta plus 2. Okay, so we need to get this. Let's try multiplying this one out. Okay, so we're going to get tan squared of theta plus tan squared plus cosine squared plus 1. Hold on. I didn't write my cosine. You guys were probably yelling at me through the computer. I didn't write my cosine squared. Then plus tan squared plus cosine squared plus 1. There we go. Okay. So let's try just changing this one first and see what happens. So sine squared of theta over cosine squared of theta times cosine squared plus tan squared plus cosine squared plus 1. Okay, these cancel. We get sine squared theta plus tan squared theta plus cosine squared theta plus 1. Let's see. Hopefully you're yelling sine squared plus cosine squared is 1 plus tangent squared of theta plus 1. Well, 1 plus 1 is 2. And that's exactly what we needed. So there we go. Okay, I think we only have about 3 more left. Okay. Okay, let's see what we can do here. I don't think anything's missing on this one. Okay. So probably going to try to get down to this side. So let's see what we can do. Let's try changing the insides first. So we're going to rewrite secant. And let's rewrite tan and see what we can get. Okay. So we're going to have 1 over cosine. And then this will change to sine of x over cosine of x. And then I'm going to just fill in the stuff around it. Okay. Denominators are the same. So let's try putting them together. Okay. Let's try separating them. So 1 minus sine squared x squared over cosine squared. We need sine, so let's leave the top alone. But let's change the bottom. So I'm going to rewrite the top. we're going to change the bottom to, what did cosine squared equal again? Let's go back and double check. Cosine squared equaled 1 minus sine squared. Oops. There we are. Okay, so now we're just going to do some algebra. So we're going to write this one twice because that's what a squared means. Oops, didn't write my 2. All over, and again, this is a difference of squares. Okay, so that means we write it once with a minus sign and once with a plus sign. These cancel. Notice what we're left with. And that was exactly what we needed. Okay. Alrighty, let's go to the next one. I am missing some things here, so let me make sure I get this one right, because this one's a little complicated. So over here, we're missing cosine x sine of y. And this is sine of x sine of y. Tan of x, tan of y, 1 minus tan of x. Okay, so this is a y. Okay. So we know that tans can be written in terms of sine and cosine. So let's start with the left-hand side first. So what I would like to do is change these tan of x's, and let's also change these tans of y's. So we're going to have sine of x over cosine of x plus sine of y over cosine of y all over 1 minus sine of x over cosine of x times sine of y cosine of y. Oh gosh, okay, so let's see what we got going on here. Definitely need to get some common denominators. So, looks like our first common denominator is going to be cosine of x cosine of y. So that means this one has to get multiplied by cosine of y. So this is going to be sine of x cosine of y plus, looks like this one has to be multiplied by cosine of x cosine of x. So this will be cosine of x sine of y all over. Looks like this denominator is cosine of x cosine. I don't think I need to go that far down. Hold on, because I'm going to run out of room. Scoot that up a little bit. Okay. So maybe like right here. So this is going to be cosine of x cosine of y. So remember, this is understood to be over 1. So we're going to have to multiply by cosine of x cosine of y. What you do to the bottom, you do the top. So this is going to be cosine x cosine y minus sine of x times sine of y. Okay, so just like the other one that we've done, we have to multiply by that bottom fraction, the reciprocal of it. So we're going to multiply by cosine of x, cosine of y, all over cosine of x, cosine of y, minus sine of x, sine of y, times cosine of x, cosine of y, all over sine of x, cosine of y, plus cosine of x, times sine of y. So notice these are going to cancel. These actually cancel. We're left with sine of x, cosine of y, plus cosine of x, sine of y, all over, whoops, hold on, OMG, I didn't write what I was supposed to right here. That was cosine of x, cosine of y, minus. You guys were probably yelling at me through the computer. But good thing I caught it when I started writing it. I was like, hold up, something's not right. Cosine of x, cosine of y, minus sine of x, and then sine of y. And if you look very closely, that now matches that right there. Okay. And just so you guys know, when you're verifying these, this work has to be there because that's what shows that it's verifying. That's why I don't skip steps. If you notice, I write every single step out because we've got to be able to follow your work to make sure it's there to prove that you truly did verify it. Okay, so let's go down to this last one. Luckily, everything on this one printed correctly, so we're good there. Probably gonna have to work on the left-hand side to simplify down to the right. So we know that we need it to be a cosine. So let's try to start by changing things to cosine. So we know that sine squared is equal to 1 minus cosine. So we're going to have cosine squared x minus, and then in parentheses, 1 minus cosine squared of x, all over 1 minus, and let's try to change this one too. And so that is sine squared x over cosine squared of x. Okay, so let's see what we got here. Cosine squared of x minus 1 plus cosine squared of x over, now we're going to need a common denominator of cosine squared here. So remember that's over 1 multiplied by cosine squared of x. So it looks like we're going to have cosine squared of x minus sine squared of x. Looks like we might have done too much work. But let's keep going, and then we'll come back and look at it. No, I think I want to fix it. Let's look at it. So notice what happened here. We got cosine squared minus sine of x. So I don't think we needed to change this one. So I'm going to put that back. So let's try it. Go multiply by the reciprocal. And what you do to the bottom, you do to the top. notice what ends up happening. These all cancel, which I guess I should have done it. Okay, but notice these cancel. Notice how I caught that, because now we're left with just cosine squared x, which is exactly what we needed. So we actually didn't need to change the sine squared on that one, but notice how I caught that to make it a lot more simple. Okay, I hope the lesson went okay. Remember, it is okay to restart over. Notice what I just did there. It's okay to change it as you're going through it, but remember the goal is to verify one side to the other. Notice I never solved for x, okay? Just be patient with these, and if you need anything, let me know.